Hello everyone, I hope you guys are able to see me live. I'm audible and I'm visible to you people. Can you please confirm that into the chat? Are you guys able to hear me people? Can you just quickly confirm that into the chat? Can you guys please confirm that into the chat if I'm visible to you people, if I'm audible to you people? If I'm audible to you people? Perfect. Perfect. So thanks for the confirmation, people. We had to delay because of certain unavoidable circumstances. I had to go into the meeting, which got stretched, but I think we are all set now to move on with our next topic of the sorting algorithms. So let me quickly share my screen. Right. Can you guys please confirm if you're able to see my screen? You're able to see my blackboard and it's visible to you people. Thank you, Ananya. Happy Teachers Day. Thank you for all the wishes across the platform, be it Instagram, be it LinkedIn, be it X. I think you guys have been so kind to me on all the platforms. So I'm really moved. Thank you for all your wishes. Happy Teachers Day. Perfect. So let's do a quick revision what we were doing previously. So we have started a topic called as a sorting. Now in the previous session, we talked about what and why of the sorting. Can you guys tell me quickly, what is the advantage of sorting? Why do we need to do it? Why do I need to do the sorting? What is the advantage of it? Can you guys quickly tell me? What is the advantage of the sorting? Why someone should think about sorting their system? What is the benefit that you go and normally get? We have seen in the previous session that at the end of a day, the whole world is craving about the data. And with data, we do only two things. We do the storage of the data, and then we try to do the computation with that data. Right? So with data, we do only two things. One is the storage and another is the computation. Now, if I want to do the computation, I need to go and first of all go and search that data. Using sorting, your search becomes fast. So when you keep your data sorted, typically it helps you in doing the computation faster. It helps you get the faster calculation. Okay, so when you go and make use of the sorted data, it always help you do the fast calculation, fast search, and that's the main use case of sorting is. In our previous session, we were talking about the bubble sort. I told you bubble sort is an inspiration of boiling water. For example, when you're trying to boil the water, what will happen? As the water gets hotter, the water bubbles goes up and the cold water comes down. Same way, in the case of the bubble sort, how it works, let's say that if I have an array that looks something like this. For example, it is 5, 4, 3, 2, something of this order. Let's say this is an array. Now, if I go and apply bubble sort to this, if I go and apply the bubble sort to this, what will happen in that case? So if we go and apply the bubble sort in this case, what I'll first do is that I'll first start 5, 4, 3, 2. I always start from this first element and I compare first two elements. If the left is more than the right, I'll go and swap it. So this becomes 4, 5, 3, 2. Then again, what I go and do, I go and compare 5 and 3. Again, 5 is more than 3, so I go and swap these two elements and this becomes 4, 3, 5, 2. If you see, this larger element initially was on left, then it moves to the right, then it moved further right. Again, go and make the comparison of 5 and 2. Again, since 5 is more than 2, this becomes equals to 4, 3, 2, 5. And if you see this 5 finally have moved to the right. The 5 has finally moved to the right. And that's why I'm saying the larger element is getting bubbled to the right. Now this is fixed. Now I'm left with 4, 3, 2. 4, 3, 2, and 5. And I know that 5 is at the right position. I again start from the 4 and 3. I go and compare 4 and 3. 3 comes here, 4 comes here, 2, 5. If you see here, 4 is again moving to the right, like bubbling. Then I again compare 3. 3 and 4 is done. 4 and 2 compare I do. It becomes 3, 2, 4, and 5. So now my 4 is also in the correct position, 5 is also in the correct position. I'm only left with first two elements. Now, third time what I can do is that I again have 3, 2, 4, 5, and I know that 4 and 5 is already in the right position. I'm left with these two. So what I do here is I go and compare 3 and 2. I see that 3 is more than 2, so it becomes 2, 3, 4, comma 5. And ladies and gentlemen, this is the bubble sort for us. Now, a quick question for you people. Bubble sort. What was the time complexity? What is the space complexity? What was the number of comparisons? What was the number of swappings? And is it a stable algorithm? What was the answer of these two things? People, can you quickly tell me what was the answer of these two things? What is the time complexity of bubble sort? Please put that into the comments if you guys remember. We saw that to do the bubble sorting, we need two for loops, one inside the another, each almost running for the size of the array. So the time complexity of the bubble sort was order of n square. Space complexity order of 1. Number of comparisons was proportional to n square. Number of swaps was proportional to n square. And was it stable? Yes, it is a stable sorting algorithm. If you have missed last session, in the last session we talked about what is a stable sorting algorithm. It's a very important concept. I would suggest you people to go back and watch that if you're not aware that which type of sorting algorithms are called as stable sorting algorithms. Fair enough? So now, since we have done a quick revision of what we did in the last session, let's focus around the today's important topic, which is selection sort. Okay. Selection sort, again, just like a bubble sort, it gives a hint that selection sort involves something called as selecting elements. So when you're solving a problem or when you're trying to do a selection sort on an array, let's say that I have an array that looks something like this: 5, 3, 1, 4, 2, something of this sort. And I want to sort it. Sort it means that if I go and finally go and sort this, the array might look something like this: 1, 2, 3, 4, 5. Selection sort says that, boss, you first fix your position. I first want to fix my position here. And then what I do is that for this position, I start searching from this position till this position. And I try to find search the smallest element index. What I do? I first of all start from this leftmost index. And from this index till the last, I go and try to find which is the smallest element, what is the index of the smallest element. So if I move from left to right, the indexes are what? 0, 1, 2, 3, 4. Smallest element is 1 and its index is what? 2. So what I go and do now is that I go and swap 1 and the 5 here, and my array becomes 1, 3, 5, 4, and 2. And my first index is done. And my first index is done. Now I am left with this element. And I am focused more on setting the right element at this first index itself. Now what again I do? I again have to go and find the smallest element index. What is that? 0, 1, 2, 3, 4. What is the smallest index? 4. So what I go and do? I go and swap these two elements. So this becomes equals to 1, 2, 5, 4, and 3. So now I'm done with this. I'm done with this. I'm standing here now. And from this point till the end, I have to go and find the smallest element index. Now from here to here, which is the smallest element? This is the smallest element. What is the index? Index is 0, 1, 2, 3, 4. So what I need to do? I need to go and swap these two elements. So swapping, it becomes 1, 2, 3, 4, and 5. So I'm done with first three elements and I'm standing here now. And from here to here, I have to go and find the smallest element. This is the smallest element. Same element, I don't do anything. And once I'm finally done, you see that this is the array which is sorted. 1, 2, 3, 4, 5, and this is the sorted array. And ladies and gentlemen, this is the selection algorithm. Does it make sense? Samajh mein aaya? Are you guys getting the point? Did you get it? How did we do it, sir? Yes, no? Can you guys just put that into the chat? Is everyone clear what is selection sort? Shall I take one more example? Will it be more clear? Thank you, Akash. Shall I take one more example? Will it be more beneficial? Or shall I go ahead and write the code for this? Any of you who's interested to do a selection sort of a given array, you can give me a sample array and we can run our selection sort algorithm to sort it out. Can you give me a sample array? Put that into the comments if you want me to do that. Any suggestions? Okay. Let's do one more quick example. Let's say that if I have a array that looks something like this. Okay, Abhishek has given this. I'll take this 99, 88, 77, 66, 55, 20, and 0. First of all, what I'll do, I'll stand on this position. This position, I have to go and put in the right element. And from beginning till end, I have to go and find the smallest. Which is the smallest? This is the smallest. So what I'll go and do is that I'll go and swap these two values. So when I go and swap these two values, this becomes 0 at the beginning. And then it is 88, 77, 66, 55, 20, and 99. Perfect. This is done. Now I'm sitting at this position. And again, from here till the end, I have to go and find the smallest. Now from 88 till 99, which is the smallest element? 20 is the smallest element. So what I need to do? I need to go and swap these two values. So this becomes 0, 20, and then it is 77, 66, 55, 88, 99. First two elements are correctly done. Now what I'm left with is that I am here, and from 77 till last, I have to go and find the smallest. Which is the smallest among 77 and this 55 is the smallest. So what I go and do now is that I go and swap these two values. So this now becomes 0, 20, and then comes 55, and then comes 66, then comes 77, then comes 88, and then comes 99. First three elements are correct. I'm here. Now from here to here, I have to go and find the smallest element. It is the same smallest element, does not happen. I move to the next. So I'm left with 0, 20, 55, 66. These all are correct. 77, 88, 99. I'm here. Now from here to here, I have to find the smallest element. This is the smallest element. I don't do anything. I again move on to the next. And I go and move to the next, it becomes 0, 20, 55, 66, 77. All of these are correct. And then 88 and then 99. I stand here. From this, I go and find the smallest element. 88 is the smallest element, does not do anything. And then finally becomes 0, 20, 55, 66, 77, 88, 99. And this is my sorted array. Am I clear, people? Does it make sense? Is everyone in the class crystal clear with the logic of how this selection sort is working, boss? How this selection sort is working? Is all of you clear on this? Is every one of you clear on this logic, people? Can you guys tell me? Perfect. So now quickly, let's move to our code and let's try to see that how we can go and write the logic for this. So let me go and open my code here. And we had a file called as bubble sort. What we'll do today is that let me go and create another file called as selection.js. Selection.js. Perfect. Let me go and write a function called as function selection sort, and it takes an array. Now I go and first write the loop for let I equals to 0, I is less than array.length. I plus plus. This is the outer loop. And now here, what we try to do, we need to bring the smallest element at the ith position. We need to go and bring the smallest element at the ith position, right? So for that, what we need to do is, let me go and find a variable called as smallest index, and that value should be equals to I. And then I go and say that for let j equals to I plus 1, j is less than array.length, j plus plus. And then what I go and try to compare if array of si, smallest index, is more than array of jth index, it means that jth index is smaller, right? And that's how I go, what I go and do is that I go and say that smallest index is now equals to j. So when I go and run this entire for loop, si will represent the index which has the smallest element. And after I'm done with this, what I'll do is that I'll go and try to swap. For swapping, I go and write it array si array I equals to array I comma array si. And that's all. Now let me bring this on my let's try to bring this code on my blackboard and let's try to see that how does it works. So perfect. So let's try to write on this code. Fair. So what I go and do now is I go and call this function like this. Selection sort. And let me go and call this function as 5, 4, 1, 2. Something of this sort. Right. So my array here is what? My array here is initially 5, 4, 1, comma 2. Now I have this outer for loop. It means that I'm first starting with I equals to 0. So first of all, I is pointing here. And this an entire loop, I'm trying to find the smaller value. I'm planning to find the smaller value from I till last index. So when I is equals to 0, I'm trying to find in this code that what is the smaller value from here till here. And how I'm trying to find it, I say that let's assume that smaller index is at the ith index. So right now in the beginning, si is also equals to 0. And then I start from I plus 1. So it means that j value starts from 1. So from here, I start comparing array si and array j. So for example, array si in the beginning is 5 and array j is equals to 4. So what I go and do? I go and compare si and j. So with this, si becomes equals to 1. Then again, the next time the for loop runs, j value has become equals to 2. I compare this value and this value. Again, 4 is more than 1. So si value has become equals to 2. Again, when I iterate next time, j value has become equals to 3. I go and compare, but I find that si is not greater than this. So value of si after this when I come out, the value of si has become equals to 2. So basically my array is 5, 4, 1, 2. I is at this index and si is at this index. What I need to do? I need to go and swap the element at si in the I index. So I go and do the swapping, and on swapping it becomes 1, 4, 5, 2. So for the first one iteration, my array has become 1, 4, 5, 2. In the second iteration, I starts from first index. It means that I starts from here. And now I have to move from I till the last. It means that from here till here, I have to go and find the smallest element. So again, through this, when I go and run it, si value will turn out to be how much? 0, 1, 2, 3. Si value will come out to be 3. And then here I go and do the swapping. I value is equals to 1, si value is equals to 3. So when I go and do the swapping, this value comes here. So after I equals to 1, the array gets transformed to 1, 2, 5, 4. Third time again, what happens? Again, this outer for loop runs. Third time I value becomes equals to 2. So now from the 2 till last, so what is the 2 index? From here till here, I have to find the smallest element in this. Smallest is this. So si value is pointing to this. I value is pointing to this. So I have to go and swap this. So this becomes 1, 2, 4, 5. When I go and do this, outer for loop is done, and this array which I have got is sorted now. This array that I have got is sorted now. Fair enough. Am I clear, people? Does it make sense? This is sorted now. Fair enough, people. Am I clear? Make sense? Very nice. So now let's try to do a further analysis of this question. So I put it up here. Let me paste the code here. Selection sort. Okay. Now the question for you people is that let's try to start analyzing this code now. That's more important part. We start the analysis of this code. If I go and ask you, what is the time complexity of this algorithm? Now, for those people who's finding it tough to calculate the time complexity of an algorithm, in our day one, which you'll find on this YouTube channel, Vishwa Mohan, on day one, we have talked about the time complexity concept. If you're finding any small doubt, please watch that because that will help you strengthen the concept around the time complexity. Now, coming back here, what will be the time complexity of this function, sir? What should be the time complexity? Any thoughts? Any suggestions? What should be the time complexity here? What will be the time complexity? So if I see here, the outer loop runs for the size of the array. So this runs for n times. And this also will approximately run for the n times. So the number of operations is proportional to n squared. So what will be the time complexity? Time complexity will also become equals to order of n square. Am I clear? Does that make sense? The number of operations is proportional to the n square. So the time complexity is also order of n square. Cool. What is the space complexity, sir? So time complexity is order of n square. What will be the space complexity? What is the value of the space complexity? Space complexity, what will be the value? Space complexity is the calculation or estimation of that how much extra space is needed. Now, if I look into this code, I have not used any extra space. Since I have not used any extra space, so the space complexity of this will be equals to constant, which is order of 1. Time complexity will be order of n squared, space complexity will be order of 1. Fair? Am I clear, people, about these two things? What is the time complexity? What is the space complexity? Okay. Now, next analysis that I want you people to do is that, can you guys tell me what is the number of comparisons? What is the number of comparisons in the worst case? What is the total number of comparisons in the worst case proportional to? In the worst case, what is the total number of comparisons that can happen? What is comparison? Comparison is this if block. How many times the if block comparison will happen? It will happen n square times. Right? Very good. This is also perfectly fine. Can you guys tell me what will be the maximum number of swaps? Number of swaps. What is the number of swaps? Swapping is happening where? Swapping is happening at this moment of time outside the inner for loop. So how many swaps should happen? What should be the number of swappings here? The number of swaps here will be as number of times the outer for loop is running. So it should be equals to n. Very nice, Shubham. Good. So if I go and try to compare my bubble sort. So if I go and talk about, let's say that time complexity, space complexity, number of comparisons, and number of swaps. If you see this, and if I go and talk about in the top, it is bubble sort. And then we have a selection sort. I see the time complexity remains the same, which is order of n square, and here also it is order of n square. Space complexity bubble sort is order of 1. Here also it is order of 1. So basically it is same. It is same. Number of comparisons, if I go and talk about it, is still n square. In the selection sort also it is n square. So this is also same. Now differentiator here is the number of swaps. Bubble sort, the number of swap that happens is order of n square only. But in the case of selection sort, it is n. So this case, this is better. So if I go and compare bubble sort and selection sort, they have the same time complexity. And still, if you have to go and choose, which should I pick? I'll go and pick selection sort because here my number of swaps are less swapping. So even though the time complexity is same, the number of swappings which will happen is going to be less. So comparatively, selection sort is better than the bubble sort. Am I clear, people? Does it make sense? Sometimes in the interview, they will ask you both bubble sort and selection sort. They have similar time complexity, same space complexity, similar number of comparisons. How do you say that which algorithm is better? Selection is better because number of swaps here are linear. Here it is quadratic. Am I clear, Goss? Is everyone clear till this point? Does it make sense? People tell me yes, no. Is everyone clear till this point? Fair? So now I want to go a little deeper. In the last session, I talked about something called as a stable sorting algorithm. Does any of you remember which type of algorithm is called as a stable sort? Do you guys remember? If you remember, can you just quickly put that into the chat? What is the example of stable sorting algorithm? Which type of algorithm will be called as a stable sorting? If you guys remember, put that into the chat, people, quickly. What is that? What is the stable sorting algorithm? If I try to cite with the help of an example, let's say that I have a code that looks something like this. 3, 3, 2, 1, 5, 9, 1. Since there are two ones, I go and represent one by another one dash. When I go and sort, very nice, Subham. When I go and sort this, there are two possibilities of the sorting. One of the possibility look like this: 1, 1 dash, 2, 3, 5, 9. And another possibility is 1 dash, 1, 2, 3, 5, and 9. If you see here, this is also sorted and this is also sorted. But in this case, 1 was before 1 dash. Here also 1 is before 1 dash. So the order remains the same. So this will be called as a stable sort. Here in this case, the order is changed. So it is called as the unstable sort. Now we know that bubble sort, which we have already seen, that is an example of stable sorting. Bubble sort is an example of stable sorting, right? Can you tell me, if I have written, let's say that, I'll be going to write the code here. Selection sort. The code is here. Think twice and then help me answer that. Is this stable or not stable? Is this stable or it is not a stable sorting algorithm? What do you guys think? The code that I have written here, is this a stable sorting algorithm or it is not a stable sorting algorithm? What do you guys think? Not stable. Chetna is saying stable. I want a reason. Can you guys tell me why? This reason is important. The fact is not important, because if you just remember and mug up that, okay, bubble is stable, selection is unstable, then it will create a lot of confusion going ahead. You should be able to logically derive that given algorithm which is there on my screen right now, it should be a stable or it should be unstable. See, when do we say an algorithm is stable? An algorithm will be stable when we have a swap in control. And basically we are trying to do in the adjacent positions. In this case, the swapping could be at the random positions. The swapping could be in the random position. Let me help you with the help of an example. Let's say that I have an array that looks something like this: 7, 2, 7, 8, 1. Now this is 7 dash because I have two 7s. Now when I run the selection sort algorithm, what will happen? I'll stand here, and from beginning till end, I'll try to go and find the smallest element. What is the smallest? This is 1. So what I'll go and do, I'll go and swap these two values. The first time what happens, the 1 comes here, and then I have 2, then I have 7 dash, then I have 8, and then I have 7, something like this. Fair. Now I am at this position. From here till the last, I'll go and try to find the smallest element. 2 is the smallest element, nothing happens. I move to the next. So it becomes 1, 2, 7 dash, 8, and the 7. Now I'm here. 7 is the smallest element, nothing happens. I stay here. Then I move to the next arrangement. 1, 2, 7 dash, 8, and 7, and I'm here. I'll go and try to find what is the smallest element from here to here. This is the smallest element, so I go and swap these two values. So when I go and swap these two values, this finally becomes 1, 2, 7 dash, 7, and 8. Now this is sorted, but the relative position has been disturbed. 7 was before 7 dash, said 7 dash is before 7. So relative position has been disturbed. Relative position has been disturbed. And since the relative position has been disturbed, this is not a stable sorting algorithm. This is not a stable sorting algorithm. Fair enough. Am I clear, people? Does that make sense? So I know that so far, if I go and talk about the bubble sort, this is stable. If I go and talk about the selection sort, this dude is unstable. Fair enough. Am I clear till this point? Does it make sense, guys? Bolo. Is everyone clear till this point? Tell me. Let me see in the, let me open my YouTube and see your comments. Fair enough. Cool. So, I have a question for you people. I have the array that looks something like this: 3, 1, 5, 2, 4. And this is the code that I have on the screen right now. Right? This is the code that I have. If I go and run this code, this will convert this array in this form: 1, 2, 3, 4, 5. What I want you to do is that I want to go and do the modification in this code, so that if I go and run this, it should go and return me the reversely sorted array. So it should look like 5, 4, 3, 2, 1. Reverse sorting. Can you guys please help me with this reverse sorting? What code change shall I do here? I'm giving you 2 minutes of time. Think over it and tell me what code changes should I do in this code so that the selection sort is sorting but in the reverse sorted order. Selection sort is sorting but in the reverse sorted order. I'm waiting for a response, guys. Can you guys tell me what can be done? What should we do? So what I have to do is that, let's try to see the logic. Let's say that I have 3, 1, 2, 5, 4. Now, if I have to convert that into this form, 5, 4, 3, 2, 1, what I'll do when I'm standing here, from here till here, I have to go and find the largest element now. And whatever is the largest element, I'll go and swap this. So instead of finding the smaller, I have to go and find the largest. So it becomes 5, 1, 2, 3, and 4. Now I'm standing here. From this point, I have to go and find the largest. Which is the largest? This fourth is the largest. So what I'll do, I'll go and swap 1 and the fourth. So this becomes equals to 5, 4, 2, 3, and 1. Now I'm left here. From here to here, I have to go and find what is the largest. Largest is 3. So I go and swap 2 and 3. So this becomes equals to 5, 4, 3, 2, 1. Now I'm here. From here to here, which is the largest? This only. So I don't do anything. And then finally, I'm left with 5, 4, 3, 2, 1. So the code change that I'll have to do here is that instead of this, where I'm trying to find the smallest element, I'll have to change this and make it less than. Very nice, Shubham. If I go and do this, this will go and sort this in the descending order. This will go and sort that into the descending order. Am I clear, people? Does it make sense? Is everyone clear? समझ में आया सबको? What changes that I'll do in the selection sort, then we'll make. Now, perfect. Now, I want you people to take a challenge question. This is the last question that I'm giving you. I'll explain that, and I'll expect you that before I come in the next session, you please solve this problem, and then please tag me if you're able to find that answer. Okay. So this is the selection sort code, sir, right? The selection sort code is on your screen right now, right? If I go and click this and put it here, this is the selection sort code. मैं बात करता हूँ जावास्क्रिप्ट के बाद क्या आएगा प्रिया? This is a selection sort. Now this is a unstable sorting algorithm, right? That's perfectly fine. Now, when you go and try to apply for the companies like Google and the Facebook, and let's say that if they have to ask a very basic question like this itself, selection sort, they will not ask you directly selection sort. They will give you the code of the selection code. They will say you that, hey, Shubham, hey, Priya, hey, Abhishek, hey, Vivek, this is the selection sort algorithm. And he will ask you, is it unstable? You will say that, yes, I have studied, it is unstable. Now they will ask you a question. They will say that, okay, it is unstable. Can you make changes in this code so that this becomes now stable? The basic of the code you cannot change, so only you have to just do a minor modification. The basic structure of this entire loop you cannot go and change. You can only do, boss, a minor modifications, and using minor modifications, can this become stable? Can I make this stable? This is the question. I want you people to give it a try. Make changes in this code. Avoid using Google. Google will have the answer. ChatGPT will also have the answer. But The purpose here is not to get the answer. The purpose here is to understand the logic, apply, understand stable, unstable concept. So my task for you people on this Teachers' Day is that go and make this a stable sorting algorithm. If you are able to do it, please tag me. And we'll discuss that as a first concept in the next session. Cool. Now, few of you people are asking that what are going to happen. This is a JavaScript stack which will keep on going. Right? We are doing right now DSA. I've already started recording JavaScript one shot, right? From the beginner, from the basic to advanced. So in the next few days, I think this will be dropped on this YouTube channel. And then after this, we can go and start with the development using the JavaScript, which includes front end, which includes back end. We'll also talk of the concept like next.js, TypeScript, right? And then deployment. So we'll go deeper into React, native. So everything which is around the JavaScript stack, we'll go and do it. That's one. I'm also planning to start, especially for the first year students, right? I'm trying to bring a playlist where I'll be teaching C and then DBMS and then networking and then operating system concept and then computer science fundamentals. Soon you will find the playlist getting started here. And number 3 that I'm planning to start is the data science stack, where we start with Python. We go and do the DSA in Python. Then we go and do the development in Python, then machine learning, deep learning, artificial neural networks, and blah, blah. Everything which is around the data science stack. So all these things will happen on the English channel. And similar thing is being planned for our English channel, which is the coding shala as well. Python abhi bas give me some time. Multiple things are going in parallel, but expect in within 10 days, you should be able to see this Python wala data science stack. Cool. Now for all you people who is watching it, on my aimers, we have started this Taiyari job key. So if you guys want to have a feel ki job ki tayari kaise hoti hai, how you prepare for the interviews and all that stuff. So this Taiyari job key we have started. The whole idea, I wanted to keep it for free, but the reason I haven't, because if I do it, my beloved competitors, they will just write some bot and script and they will just hijack my database with huge amount of DDoS attack. Just to do it, we have kept it a very nominal price, which is less than a price of a pizza or less than a price of 2 people going out and eating Maggie in the canteen. So please try it out. If you know your friends, seniors, juniors who can be benefited, please suggest them. Especially it is for the people who want to understand the job scenarios, how interview happens, how do we prepare for that, how do we create the right resume, right? It's gonna be super, super helpful. 7-day workshop, not 1 or 2 or 3. It's 7 days, everyday life. Plus you get the access to the Aimers platform. Plus you get the unlimited mock interviews. Plus you get the support to build the high, uh, ATS qualified resumes. So please do this. And again, once again, thanks a lot for your wishes. Happy Teachers' Day. I wish you guys all luck. You guys do amazing work. Keep on working hard for your career and make it big in the IT. Thank you, everyone. Good night. Next day, I'm awaiting that you should be able to write the code and convert that into the stable sorting algorithm. Please give it a try. And if you're not able to solve it, that's great. But don't look over the internet. Don't check for the solution. Purpose is not to find the answer, but to how to solve it. Fair enough. Thank you, everyone. Good night. Take care. So with